So after step 3, which is find the general form, we do step 4, which is to find our constants. And we can use a method called undetermined coefficients or equating coefficients of like powers. So our original problem here, we had 2 over x squared minus x minus 2. And the general form of that was a over x minus 1 plus b over x plus 2. Okay, so we did that in step 3. That was right here. So actually, I guess we have them switched, plus 2 and minus 1. So what we want to do is solve for a and b. So let's multiply through by the LCD here. So multiply on the left and also on the right by the LCD to clear out fractions. So on the left-hand side, x plus 2, x minus 1. And also on the right-hand side, x plus 2, x minus 1. On the left-hand side, these cancel because that's exactly how this factors. So we're left with a 2. On the right-hand side, this whole expression comes in times each term. When you multiply these, the x plus 2's will cancel. You're left with a times x minus 1. Plus, when you multiply this one times the second term, the x minus 1's cancel. You have b times x plus 2. Now, these two expressions are equivalent for all values of x except when the denominator is equal to 0. Because this expression is undefined. However, if they're equivalent for all values except the denominator, that means that we can plug in values here that would be equivalent to plugging in values there, and the equation's still valid. So what we're going to do is this has to be true for all x values. So we're going to plug in x equal 1. Left-hand side equals 2. This will be 1 minus 1. So you just get a times 0 plus b times 1 plus 2, so 3b. So that zeroes out. So we get 2 is equal to 3b. So you divide both sides by 3, your b is equal to 2/3. And then we choose x equals negative 2, which is the other 0 for the denominator. And we get 2 equals, this will be negative 2 minus 1, negative 3. So negative 3a plus b times 0. So that zeroes out. We've got 2 is negative 3a. Divide both sides by negative 3. So your a is going to be negative 2/3. And if you'll remember, those are exactly the coefficients that we had when we simplified the expression of this form. They were 2/3 and negative 2/3. So what does that mean? That means that this 2 over x squared minus x minus 2 is equal to a is negative 2/3. So negative 2/3 over x plus 2 plus b we found was positive 2/3 over x minus 1. So if we want to integrate this, that means that we integrate negative 2/3 over x plus 2 plus 2/3 over x minus 1 dx. So take the integral of each piece, pull your constants out, So this would be negative 2/3 integral 1 over x plus 2 dx plus, pull this 2/3 out in front of the integral, and integral 1 over x minus 1 dx. Now this looks like g prime over g. And remember, antiderivative g prime over g is natural log. So this is negative 2/3 natural log absolute x plus 2 plus 2/3. And same thing here, g prime over g. So ln absolute value of x minus 1. And then plus constant. So go ahead and copy this. If we go back to our original problem, yeah, we wanted to integrate this thing, and we did. Okay, this integral is equal to that. And here, if we had a problem like this, then we would just integrate the pieces separately. We integrate 3x squared minus 1, just get x cubed minus x, and integrate this one and get this. So using partial fractions. So that is the method of partial fractions complete all the way through. And again, what makes this work is that these expressions are equivalent for all values except the zeros in the denominator. But if these two are equal for all values except the zeros in the denominator, then they'll also be equal for the zeros in the denominator, even though that doesn't happen here. And it's the zeros in the denominator that you want to pick over here to plug in, because that simplifies your equation and makes one term drop out so you can solve it.